So good morning, everyone, for those in the US, and good afternoon to everyone in the UK. Welcome to the BD2K Technical Conference. Today we will have one presentation, which is about the BD2K Aztec. We are scheduled to start at around 8 Pacific time and end at the latest 9 Pacific time. While this presentation will be recorded, this presentation will be recorded and posted online once we've published them, processed them. If you have any questions during the presentation, please type it in the message box provided in the application. And also, please mute your mic during the presentation to prevent any background noises. Brian Bleakley, Chelsea Ju, and I, Vincent Key, will be presenting about BD2K Aztec. I'll be starting with a brief overview, and then Brian will give a quick demonstration, and then Brian, Chelsea, and I will answer any questions and hear any suggestions or feedback you may have. So BD2K Aztec is a global biomedical resource discovery index. The resources index include web services, standalone software, publications, and large libraries composed of many interrelated functions. So BD2K Aztec will incorporate resource metadata from 4 primary sources, all tools created by the BD2K Centers of Excellence and the BD2K Targeted Software Development Program will be added to the database by our reviewers as they are released. 2, we will use sophisticated text mining techniques to garner metadata for newly published tools from a host of biomedical publications. 3, an online forum will be available to streamline author-initiated submissions that follow our metadata standard. And 4, Aztec will extract metadata from a global federation of script libraries and source code repositories as new release of biomedical software becomes available. But we will primarily focus our efforts on the BD2K resources, and in parallel, we are incorporating the resources mined from scientific literature, author submissions, and the global federated resources. In terms of our resource metadata, all Aztec tools will be indexed using a unique accession number consisting of the prefix AZ followed by a non-consecutive integer. The metadata for all tools in Aztec will be standardized using a combination of internal collections of enumerated types and will establish external unique identifiers and ontologies. Aztec will be both searchable and filterable by all the metadata fields shown above through both the website and the RESTful API. We'll be using the EDAM ontology to explicitly define the biological domain, function, data types, and data formats associated with each entry. In terms of the identifiers and ontologies, we'll be using well-established ontologies such as EDAM. We'll also aim to incorporate ORCID logins, which uniquely identify authors of scientific publications and datasets. Currently, ORCID has over 1.5 registrants. With regards to external identifiers, we are using DOIs, or digital object identifiers. Authors of tools without DOIs can request a new DOI, which will be minted by DataSite through our partnership with the California Digital Library. Here we have a figure of our overall diagram illustrating the architecture and workflow of Aztec. The web application of Aztec provides easy access to biomedical resources. Starting at the top of the diagram, you'll see the users can interact with Aztec through a built-in graphical interface written in HTML, CSS, and JavaScript, or directly through the RESTful API. On the left side, we show the initial resources that are retrieved through publicly accessible registries and converted into JSON format. And on the right, we demonstrate that Aztec also provides a platform to incorporate data from 4 primary sources, as I mentioned before. And on the bottom, we have the different technologies that are used to support our search service. So going into more detail on the technologies, we are using MySQL to preserve the data integrity. Solr is the main platform search platform that's used to index the resource metadata. We're using MongoDB to store statistics and used by our search history functionality. And we hope to incorporate Neo4j to map the relationships between all tools, including the upstream and downstream tools, as well as the versions of the tool. And in general, we're using Node.js with a model view controller design pattern to create our web application. So now Brian will give a brief demonstration of Aztec.
Hi everyone. So I'm going to go here to the main Aztec site. So as you can see, we have a search bar. We try to keep it simple. We want it to look sort of like Google. Try to get rid of all the distractions on the main page. If you scroll down further here, we have some graphics showing the current number of tools in the database, showing the current population of different types of tags, and here's display of the different types of platforms that are available. Let's say I'm going to go ahead and do a search here for gene, and you can see I get 440 results. See, something I can do a sub search here. If I go to advanced, I can come down to sub search, and then I can do sub search for DNA, and then you'll see that it has both gene and DNA, and I have a limited number, only 20 results here. And then also, this is on the left-hand panel, we have a set of filters, and this is based off of the sort of Amazon.com model, where you search, and then on the left-hand side, you can filter your results to get only specifically what you're looking for. I'll give you an example of what a tool page looks like. We can see you have mygene.info here. This was taken from Bioconductor. So here's the R package for mygene.info. And in this particular, so we are, as Vincent mentioned, we are manually going through and adding in some tools that don't exist in some of the source code libraries that we're automatically mining. And we're doing that for BD2K with our focus on the BD2K software tools. But in this case, mygene.info, this information wasn't entered in manually. It was all automatically pulled from Bioconductor. So we have source code links, documentation links, language, platforms, authors, maintainers, dependencies. And then we have some miscellaneous tags. So I'll go show some more advanced features we have running on the development site. We have just a little more fluff material up here describing the purpose of Aztec, and then giving an example of the metadata, that sort of thing. We also have a login system to register. So here I want to register a new tool. Let's say something that I've developed is not in the database. Well, I can't register until I log in. Okay, the login is under development, so this is just a temporary placeholder profile page. But now when I go to register a new resource, it's available. So it's going to associate that I registered this with my account, so that I'll be able to come in and edit a tool if I am maintaining it, or I can pass on control over the tool to another user in the future. So you can see here I can register a new resource. We try to put in suggestions here. We probably could put in example data types of so it's clear to the user what we're intending, and we have tooltips here that go into more detail. What we're currently working on now is a recommendation system. So let's say I type in a tool here called like super search. So if the name of the tool is super search, and then I'm coming down to, like, for example, source code URL, the Aztec will automatically search GitHub, find out if there's a tool called super search, and then be able to match, for example, the language. If I say super search is written in R, then it'll query GitHub for a tool called super search written in R, and then it'll automatically populate with that source code URL and say, is this the source code URL you want? So that's a project we're currently working on. And also do the same thing for publications by searching PubMed and other databases like that to try to make it as easy as possible for both people within our lab to register new tools and edit new tools, and go in and correct mistakes, and also people outside the lab who aren't really familiar with our registration process. Let's see. So those are about all of the different features we have to demonstrate. Now I could go back and show some of the so a few of the things that we're working on that maybe a bit further down the road. Using Neo4j, like Vincent mentioned, to build these sort of relationships between tools in terms of what's an upstream tool, what's a downstream tool, what would the actual workflow look like, and then sort of also based off of the sort of Amazon.com model, having the similar resources. People who are looking for a particular type of tool, what did they ultimately find and ultimately use? So these three here are just samples, but soon we hope to have a good alternate tool recommender working.
Okay. In terms of our current developments, as Brian mentioned, we're still working on the login system. We're working to polish it up and hopefully have the login system running by the all hands meeting. And we're also looking to redesign our tool submission form to polish it up and have a nicer looking graphical interface. And we're also looking to fill in the metadata that's missing in the metadata in Aztec. So these three things are currently in development, as well as the functionalities that Ryan mentioned before.
Could I ask Chelsea to give more specifics on the design, the creation of the user login system? I know she's the main driving force behind of that, and she spent so much effort. And Chelsea, do you want to say a few words about it?
So currently the login system is the main purpose for the login system is that we need to be able to track like who creates a new tool to the system, and then so the user is able to edit their own tools, go back and edit the information, because we don't want anyone to edit everything. And right now, the logins is, so basically when you comes in, you just have to register with your email address and your name. Can we actually show that page? Yeah. So basically, we provide a very simple sign-up page, and people just have to provide your own email address, the password, and the first name and last name. So once you sign up, we'll send an email as a confirmation saying that you already registered with us. And after that, you can log in with the email address and then do basically register new tools with us. And right now, one of the other components that we are working on is trying to make sure the sign in and the login, the system is secure. So we're going to create this secure channel using SSL certificates to make sure that basically to provide this confidential channel for the users. The other feature that we are working on is once we log in, we can see the profile page. Don't think really showed the.
Okay.
So once we log in, they show a very simple profile information, but on the right-hand side, we're hoping to list out all the tools that you basically registered with us. So it provides an easy access if you want to change your tools. So that's basically the basic idea, what we are aiming for at this point.
Thank you, Chelsea. And Brian, could you also share the challenges we have on the metadata forms with others? So maybe we could get advice and input from Henning and Andrew as they're more familiar with the issue. Like how many of the tools we currently have in the system are containing incomplete or missing metadata forms.
Yes. So when we showed in this presentation the resource metadata, the vast majority. So we're manually entering some tools, but the majority of them are coming from repositories like things like Bioconductor. So in a lot of those cases, they don't have these different things pre-populated. Like Bioconductor doesn't have any mention of funding, anything like that. So and then every sort of repository we pull from is a little bit different. So we're trying a couple of different approaches for that. So one thing I mentioned is some information like if you want to know the source repository for a tool and you don't find it in the original index you looked, well, you could directly search, like SourceForge or GitHub or a well-known source repository, so you can find it there. You do the same thing for publications for PubMed. It'd be difficult to do the same thing for funding and award numbers. That might have to be done manually, but there's other databases out there that aren't where the tool doesn't necessarily have its own entry, but you can still search to find that missing metadata. But as Pepe mentioned, it's difficult because there's just a lot of no, I wouldn't say inconsistency, but irregularity between the different repositories that we're getting the vast majority of our tools from. So we do have a lot of incomplete. We do have a lot of tools where some of these fields just aren't populated. So that's going to be part of our effort to identify tools with very few fields populated, and then using the editing page here on the development site. So somebody working in our lab or somebody else will be able to come in and edit the resource, and we'll do a few of those queries to be able to populate these things with suggestions that the person will have to approve. So that's our so we're going to identify like the most problematic tools, the tools with the least amount of metadata, and then those are going to show up sort of higher on a queue for somebody to come in and view this editing page to be able to do some manual curation. As Pepe mentioned, Aztec is we've done a lot of work so far, but it's still really early on in development, and a lot of things aren't really finalized. So we're really curious, sort of the target audience, researchers, tool developers, what sort of things would you be most interested in a resource like this? What sort of features would you be most interested in? How do you see yourselves using a tool like this in your work?